In this video, I'm gonna briefly introduce the system architecture we built for Twitter analysis. As shown in the slides, this is the architecture of our system. The system is automatically deployed using Ansible Playbook and applying instances from Melbourne Research Cloud, as known as MRC. The system consists of a CouchDB cluster, a data harvester, a data analyzer, and a web-based app that visualizes the results of the analysis. I will go through the above components one by one. Firstly, to get better load balancing, three instances, namely instance 0, instance 1, and instance 2, each with two virtual CPUs, 9 GB of memory are allocated from MRC, are set up as a cluster of CouchDB. Each node of CouchDB is deployed in a Docker container, and the volume is mounted to the disk of the system. And there were 100 GB of volume allocated to each instance so that we can maintain the data even if the instance crash. Then we deployed our front-end page in a new instance called instance 3. We use Flask to develop the web page of a result visualization purpose. The Flask app is deployed using Docker Compose with port 5000 inside the container. And the port 80 of the system will map to this Docker port 5000 so that the user can access the IP address without typing in a port number. Finally, the data harvest and the analyzer can run in any of 4 instances. The details will be introduced in another video. And in this project, the Ansible Playbook is used to implement scripted deployment capabilities. We executed the running shell, which use Ansible YAML files to automatically implement this project, including launching instances from Melbourne Research Cloud, installing Python module such as Docker and CouchDB, and deploying the data harvest analysis code and setting up several front-end visualization. According to the MRC examples code provided by the professor, we sequentially run the task inside the rows shown in the figure below. We install the OpenStack module to access the MRC, create 4 instances for instances we will launch, and set the security group of those instances. Then we applied 4 instances and transfer their IP address to the Jinja2 templates to build real share file used after. The next step is to set Docker configuration. We firstly need to set the proxy both for instance level and for Docker level. And then we can install the Docker Compose module using the apt and pip modules in Ansible and pull the CouchDB using Docker. Then we configure the CouchDB cluster on 3 database instances. We upload corresponding share file to each node through Ansible and execute them on the instance side. The subnodes only need to create the CouchDB container. Besides, the master node is required to set up the database cluster and add all 2 subnodes into the created cluster. The final stage of our deployment is setting up the web server of our application. We upload the share to the web node instance and execute the front-end code packaged by Docker Compose, which maps the access port to port 80 of the web instance and executes the web server, and it launched. So basically, it covered all I want to say. and thank you for listening.